Section 6.8. I can add, subtract, multiply, and divide complex numbers. Yesterday, remember, we talked about imaginary numbers. Which were any number in the form of bi. So for instance, 5i is an imaginary number. Okay? Well, today we're going to talk about complex numbers. Now, complex numbers are an even larger number system that include the real numbers and the imaginary numbers. Complex numbers are in the form a plus bi, where a is the real number part and bi is the imaginary part. Okay, so if I have, for instance, 5 plus 0i, well, that's just equal to 5. So that is a real number. Okay, so that's in the real number system. If I have 0 plus 6i, well, that's just really 6i, which is an imaginary number. But if I have something like 5 plus 6i, well, that has a real number component and it has an imaginary component, and so we say that this is a complex number. Okay? So in order to add and subtract complex numbers, all we do is combine the real parts together and we combine the imaginary parts together. So for example, if I have the complex number 4 plus 5i plus 8 minus 7i, I take the real parts, which are 4 plus 8, plus the imaginary parts, which are 5i minus 7i, and I just combine them. So 4 plus 8 is 12, and 5i minus 7i is negative 2i. And so the most simplified form of that would be 12 minus 2i. So in other words, we just combine the real number part and we combine the imaginary part. And we end up with the complex number 12 minus 2i. Example 2. 3 times 2 plus 4i minus 2 times 4 minus 5i. Well, just like always, when we see a number outside a parenthesis, we distribute. So that's going to be 6 plus 12i. And I'm going to distribute the negative, which is going to give me negative 8 plus 10i. Because I'm distributing a negative 2 and a negative 2. Now, I just combine the real number parts. So 6 plus negative 8 plus the imaginary part, 12 plus 10, or 12i plus 10i. So 6 plus the negative 8 is negative 2. And 12i and 10i is 22i. Okay, so that is the sum of those two complex numbers. Now for multiplying, we, number one, use FOIL. And number 2, we use the fact that I squared equals negative 1. So we use both of those concepts to multiply complex numbers. So, for instance, example 1, if I have 2 plus 3i and 3 plus 4i, and I want to multiply those two together, well, I do just like I would do with FOIL. So basically I'm going to take 2 times the second parenthesis plus 3i times the second parenthesis. Then I'm going to distribute. So 2 times 3 plus 2 times 4i plus 3i times 3 plus 3i times 4i. Then this simplifies to 6. This simplifies to 8i. This simplifies to 9i. Now here's where you have to be very, very careful, because you do the 3 times the 4, which gives you, which gives you 12, and then I times I gives you I squared. But remember, I squared is really negative 1. So I have 6 plus, and I can combine these, 17i plus 12 times negative 1, which gives me negative 12. And I can combine the 6 and the negative 12 because they're both real numbers. So it gives me negative 6 plus 17i. Okay? And that is the product of the two complex numbers. Example 2. If I have 2 plus 5i, quantity squared. Well, remember, because of this plus inside, I cannot distribute the power, so I have to write it out twice. Then I just FOIL. So it's going to be 2 times 2 plus 5i plus 5i times 2 plus 5i. Distribute. 2 times 2 is 4. 2 times 5i is 10i. 5i times 2 is 10i. And now here's where you have to be careful. 5i times 5i is 25i squared. Combine our i's here, but remember, I squared is really negative 1. So I really have 4 plus 20i minus 25. And so I can combine the 4 and the negative 25 because those are both real numbers. So I get negative 21 plus 20i. Okay? And number 3, I have 3 plus 2i and 3 minus 2i. Now notice here that the two parentheses are conjugates of each other. So just like when we were multiplying binomials with radicals, when we had conjugates, the radicals were eliminated. Well, when we're multiplying conjugates with imaginary numbers, the imaginary number gets eliminated. So look what happens. We distribute just like we would, so we're going to do 3 times 3 minus 2i plus 2i times 3 minus 2i. Distribute, so 3 times 3 is 9, 3 times negative 2i is negative 6i, 2i times 3 is positive 6i, and now here's again, be careful, this times this gives us a negative 4i squared. Okay, that multiplying, when you do this multiplying, that's where most students make mistakes, so be very careful. So notice that these add up to 0, and remember this I squared is really negative 1. Oops. So negative 4 times negative 1 is a positive 4, so I get 13. 13 is my final answer. Okay? Number 3, dividing complex numbers. Okay? So for instance, 6 over 1 plus 3i. This is like a binomial, so you put it in parentheses. And just like with radicals, what we're going to do is we're going to multiply by the conjugate. So the conjugate's going to be 1 minus 3i. So 1 minus 3i. So it's going to be 6 times 1 minus 3i. And on the bottom, I'm going to FOIL. So it's going to be 1 times 1 minus 3i plus 3i times 1 minus 3i. So I get 6 minus 18i on top. On bottom, I'm going to get 1 minus 3i plus 3i. Now again, here's where we have to be careful. Negative times negative gives me a positive 9, and then I squared. Then these add up to 0. This is really 1 plus 9 times negative 1, which is really 1 minus 9. One minus 9 is negative 8. Now notice that there's a common factor of 2 in each one of these. So I'm going to factor out of 2 out of the numerator. And then this reduces with this, gives me a 4. So I get 3 minus 9i over negative 4. And normally we write that in this form, in an a plus bi form. So it would be negative 3 over 4 plus 9i over 4. So this is in the form a plus bi. So that's normally the form that we write that in. Okay? Right. Now we also can look at what are called complex functions. Actually, before we do this one, let's go back and do one more where we have to basically rationalize the denominator. Example 2 would be find the reciprocal of 2 minus I. Okay? Well, the reciprocal of 2 minus I would be 1 over 2 minus I. Then we have a complex number in the denominator, so we put it in parentheses, and we want to get rid of that complex number, so we multiply by the conjugate. So on the top it's 2 plus I, and on the bottom it's going to be 2 times 2 is 4, plus 2I minus 2I, and then remember again, be careful with this last one. So that's going to be negative I squared, but that's 2 plus I over 4 minus negative 1, which is 2 plus I over 4 plus 1. Because remember, a negative times a negative, or a negative negative makes a positive. So we get 2 plus I over 5. And that's 2 over 5 plus 1/5 I. Right, now let's go on to complex functions. So, example 1. Let's say I have f of x is equal to 2x minus 1 over x. And I want to find f of 3 plus 2i. Okay? And so what I do is in the function, wherever there's an x, I put a 3 plus 2i. So I do f of 3 plus 2i is 2 times 3 plus 2i minus 1 over 3 plus 2i. So all I did was replace everywhere there was an x I replaced it with a 3 plus 2i. Now it's a matter of just simplifying. So distribute. Okay, so we have to get rid of this complex number in the denominator. So we're going to multiply by the conjugate. And so this is I'm going to put this in parentheses so I remember to distribute this negative later. It's going to be 3 minus 2i over, and then we're going to FOIL the bottom. 3 times 3 is 9, minus 6i, and then 2i is plus 6i. And then again, remember, this is where you have to be super, super careful. So 2 times negative 2 is negative 4. I times I is I squared. Again, that part, this times this, is where most mistakes happen. So be very careful. So we get 3 minus 2i. This and that add up to 0. This negative, or I squared is really negative 1, so that's going to become a positive 4. So it's going to be 9 plus 4. So I get 3 minus 2i over 13. Okay. Then I want to be able to add those, so I need to get a common denominator. So I'm going to multiply this top and bottom by 13, so I can get a denominator of 13. So if I distribute this 13 through, I get 78 plus 54, whoops, I got my 4 there. 78 times, let's see, that's going to be 2, carry the 1, 52i over 13 minus 3 minus 2i over 13. Now I have to distribute this negative through here. So I get 78 plus 52i minus 3 plus 2i all over 13. So I get 75 plus 54i all over 13. And to break that up into the real part and the imaginary part, that's our final answer.